ఆన్ చేసిన జస్ట్ చూస్తున్నా. Good morning. I just want to tell you, I'll stop.
ఒకసారి ఇట్లనే చేస్తే మళ్ళీ రాలేదు, వాళ్ళు వచ్చి డిలీట్ చేస్తేనే వచ్చింది.
Good morning, everyone. Okay. Okay, I will do it. Maybe you can go to department because he is feeling very bad. Huh? Okay. Okay, got it. Yeah. Good morning, everyone. How are you all today? Hope you had great weekend. So let's start. This is a really new topic which I am going to discuss. This is about genetics. I think you all have some idea about genetics. Did you all hear about it? Did you all hear about what genetic means? Genetic disorders, defects. Yes, no. Okay. Let's start because it is time is up now. It is exactly 9:31. So we'll close our session at 10:15. As you all know that I am Dr. Sugna. I am the professor in Department of Community Medicine. Just to remind you all that I have joined the department very recently. Okay. Am I audible to you all? So genetics and health go together. Ultimately, what we express ourselves, our behavior, or whatever it is, like it is genetic makeup of a person. So genetics, all the genes, they are very much related to well-being of an individual. The health of a person depends on the genes which he or she carries with them. Did you all hear about Mendel and Darwin? Their theories which we will be discussing. I think in biology you might have heard about Mendel's laws, then Darwin's theory, etc. In biology. Did you all hear it? Yes, no? Okay. So now let's start. What are our specific learning objectives? In every session you have some learning objectives. The learning objectives are very specific. You know, they are not broad, they are very specific. So all of you who are in my class, at the end of the class you all should be able to classify the genetic disorders. You know, there are so many disorders related to genes and you should be able to classify them. Next important objective is you should be able to list 7 ways in which how these chromosomal abnormalities occur. We all are made up of chromosomes. So there are so many chromosomal abnormalities which exist in the world related to human beings. So you should be at least able to list 7 ways how these chromosomal abnormalities occur, and then at least enumerate 3 disorders related to sex chromosomes, and you should be able to define what Hardy-Weinberg law is. Introduction. Coming to introduction, there are 2300 hereditary diseases identified, and then they have emerged. Let me just tell you how these chromosomes were identified. The chromosomes were identified under the microscope, and they have found out saying that there are 26 pairs of chromosomes in human beings, and they have identified under the microscope. Out of those these chromosomes, there are 2 sex chromosomes, other all are autosomes. Okay, so the sex chromosomes, you all know, it may be XX or XY. So they have identified that. And why it is important to identify? It was identified in 1950s about what chromosomes are. Later in 1956, 2 persons whom I am going to tell you all, show the pictures, they said that there are 26 pairs of chromosomes. There are 26 chromosomes, and then they also said that later in 1960s they found that the abnormalities which occur in human beings due to genes, they are related to chromosomes. So every person, they carry the chromosomes, and they are from our parents. The chromosomes, usually they are the same chromosomes which the parents have, but sometimes when they are forced to change because of various reasons, then there will be a presentation of abnormalities. Once a newborn is born, when a newborn is born, and when we see some defects which may be related to abnormal chromosomes. So that is how they have found. And then in 1970s, they said that there are an ample number of disorders. It may be related to, which are related to chromosomes, but they are very rare. Most of them are like hereditary diseases. So why do you want to know about the hereditary diseases related to genes? We are interested in knowing about it because we can see the risk factor for the recurrence of that disease or of the defect, chromosomal defect. It can be Down syndrome, it can be Klinefelter syndrome, it can be Turner syndrome. I think which you all will be reading in your pathology. I do not know where because your pathology classes where you stand, but they will teach you all. That is purely related to the number of chromosomes. So in most common defects which they have found in 1970s it is the trisomies. I'll tell you all about what trisomy is. Down syndrome is a defect. It is a defect in trisomy. How it happens, why it happens, all these are means it is not required for undergraduate, but you should know that all the defects or the abnormalities are related to 2 important components of the chromosomes. It can be number, it can be structural defect. The structural defect, again, it can be of various types which I am going to discuss. I have 2 classes on which I had to take you all on genetics and health. So in the first class, today's class, I will cover as much as possible, and then I will roll over in my next class. So when they have found in after several years, they were going on concentrating on these hereditary disorders, and around in 2002 they found that there are nearly 2,300 hereditary diseases which they have identified, and they understood that it is related to health and disease. And what are these factors? These chromosomes are endogenous factors. They are not exogenous. What are exogenous factors? Exogenous factors are the factors in which we live. Environment, physical environment, biological environment, etc., etc. So all those social environment, which is very important, which we come across people every day, every moment of our life. So those all are exogenous factors, but the chromosomes are the endogenous factors, and they are very much related to health and disease. There are several branches of this genetic related to genetics. So one important thing is about the cytogenesis. Cytogenesis is dealing with the cells of the genes, how they are, what they are and all. Then the biochemical, you all know about biochemical. You all have passed biochemistry, I think. So you know what biochemistry means. It is related to chemical structure related to the life, biology. So biochemical, and the clinical aspect, then the pharmaco, that is related to therapies, because if a pregnant woman uses some drugs during first trimester of pregnancy, it can result in a defect because the chromosomes are disturbed because of the effect of the drug when they are dividing in the egg form. That meiosis, mitosis, all these things you all are aware of it. You have learnt in your intermediate. Then the immunology, then the microbiome, and of course your genetics, population genetics. That is a specialization which is rapidly evolving. Then last comes the genetic engineering. What is genetic engineering? Any engineering is repair. Like doctor is a teacher, engineer is a one who repairs. So genetic repairing, so he wants to control the traits which will result in abnormalities. That is genetic engineering. Is it clear to you all? Coming to chromosomes, I was telling about it that there are 22 pairs of autosomes and a pair of sex chromosomes. So who was that who have identified it? It is Tizot and Levin in 1952. They found that these chromosomes, they have identified the chromosomes in under the microscope in human being. And what did they say? They have identified that a normal human body, a normal human man or a woman cell contains 46 chromosomes. That is, it comes to 22 pairs of autosomes and 1 pair of sex chromosomes. Total is 46 chromosomes. And how do they look? You all have studied in it, but I will be telling you all. They are like condensations. They look like a rod of chromatin, and it always occurs in pairs. And where is it found? It is made up of DNA, RNA, all these things you read in your biochemistry. Do you all remember? Yes, no? You had to remember. Or you can go back and just go back and read once so that you'll remember. And how do they look like? They look like they are arranged in the form of a necklace, like beads. And the number in each species is always fixed unless it is forced to change. I repeat, unless it is forced to change. Forced to change by what? It can be by anything. It can be by taking drugs in the first trimester, which may have an effect during when the cells are dividing that time, and then they are disturbed. Once they are disturbed, then it results in abnormality. These 46 chromosomes, they are also called the diploid number. So half of it are called haploid number, and each pair of chromosomes, they are always, it is homologous. Homo means same, they look same, and they are always numbered. Coming to sex chromosomes, which are 2 in number, 1 pair. It can be XX for females and it can be XY for males, and they are not numbered. Why they are not numbered? They are just 2 in number, so we don't have to number it. They haven't numbered it. And what are they called? It is called X chromosome and Y chromosome. In females, they have 2 XX chromosomes. sex chromosomes, and in a man it is X and Y sex chromosomes. And how do they look? The X as a bar body and or sex chromatin looks dark at in the staining area at the periphery of the cell nucleus. When there is a nucleus, it goes and stays at the periphery of the nucleus, the bar body. Autosomes are again divided into 7 groups, A to G, and Y chromosome belongs to group G, and it is 21 and 22 pairs. X chromosomes belong to group C. They are in 6 to 12 pairs. If I am fast, you can stop me, but I don't know where you all are going to chat, because I will find out whether you all can chat with me directly and I can give my number to you all. Let me find out from the department. Okay. Then coming to studies. How they have conducted the chromosomal studies. They have taken the buccal smears, then the peripheral blood smears, then they have collected the blood from the bone marrow, then they have taken from the skin, from the testis tissue, and what did they do? They have cultured the cells, and then they also have done fluorescent staining of what? Of these chromosomes, and they have studied it. This is how they have studied. This is all for information, so that you all should have a broad means you should have a broad concept of what genetics means, how it is done. It is very much related to health and your well-being of any human being. So, what is mitosis and what is meiosis? When the chromosomes divide lengthwise, they are into chromatids, they adhere at the center. Because they are adhering at the center, it is called centromere. And they always divide lengthwise. Okay. Meiosis, what does it means? It is the reproductive cells which undergoes 2 divisions at the nucleus level and only 1 chromosome division, and it is a reduction division. It will reduce, the number reduces when they are dividing. That is meiosis. Please remember that. It's very important. Genes. What are genes? I was telling you all about the chromosomes. Now let's talk about, they are nothing but they are the chromosomes. Genes, nothing but they are the chromosomes, and they always occur in pairs, and it can be heterozygous or homozygous, and they are always stable. I was telling you all, again and again I am repeating that they, unless they are forced to change, they do not change, and then they give to the offsprings the same amount of chromosomes which they have to the child. So they are always stable. Very few are unstable. We'll see the reasons for it, and then how we can do it, why we want to do it, why we want to know it, how it will help the parents to decide. Okay. So mutation is again division, and it can be normal or it can be abnormal. Anything can happen, and always remember that the dominant effect will always manifest itself in both homozygous and heterozygous things. Then always when it is an homozygous effect, it is recessive. It is not dominant. Means when the presentation of the child with the disease comes, it is to a lesser extent other than when it is dominant. When it is dominant, the effect is more. When it is recessive, the effect is less, and it is always encoded in chemical structure. We don't have to know about it. We just have to know that it is in a chemical structure and it is encoded. And always the disease is transmitted from one generation to another. Like for example, I will tell you all about sickle cell anemia. which again you will be learning in your pathology. In sickle cell anemia, it is the cell, red blood cell. Okay, that red blood cell, it is genetic, because of the genetic disorder, the same gene is passed from the mother to the child. Okay, that is what I mean to tell you all, that the disease is transmitted from one generation to other, and it always has an effect on development and function. Once the child is born crippled, like for example Down syndrome, then hydrocephalus, then what happens? The development is delayed and ultimately they cannot function like a normal person because of the defect, because of the development. So that is what we have to concentrate, and how best we can help the couple to avoid the future pregnancies, and what is that happened for the means when an abnormal child is born, what is the probability of second child being born as similar to the first child. So how we can prevent? By studying the genes of both the parents. And so development and function, it can be both normal, abnormal. I already told you all. What is genotype? Genotype is nothing but the genetic constitution of the individual. Each one of us have a genes, and what we present ourselves, it is the total genetic constitution of our individual. Each individual, like me or like all of you, every one of us, we present what we have in our body. That is the total genetic constitution. Phenotype is what? It is expression, what they see outside, how you behave, how intelligent you are, how healthy you are. That outward expression is phenotype. In the genotype, we study the constitution of the individual. That is mainly, it is lab. In the phenotype, it is expression, what they see outside. And what is medicine? Medicine is nothing but it is the management of the human phenotype. Whatever we see outside, like a mother who gives birth to a Down's syndrome, Down's baby, then it is expressed, we can see it, and it is for the physician to manage that baby and also counsel the mother and the father of the child how to take care and also how to avoid further pregnancy by doing counseling and asking the couple to undergo genetic investigations. Mutations can occur because of when the pregnant women are exposed to ultraviolet rays, radiation, X-rays. We'll say, if we'll ask every female who comes to us, whether ask for the history of whether she has missed a period. Why do we want to know that? Why we want to know whether she is pregnant? If she is in the early pregnancy, we want to avoid X-ray exposure. That's why we want to know about it. Because why we want to avoid X-ray? X-ray itself can result in mutation of the genes, which because she is in the early period and where there is division of the cells. We don't want the X-ray to be done so that there will not be any abnormal mutations which may result in abnormal child, birth of an abnormal child. In addition, we also want to avoid carcinogens, chemical carcinogens. What are these chemical carcinogens? Any drug, antibiotic, we want to avoid in early pregnancy. That may have an effect on the first 3 months when the embryo is getting formed. So we don't want the abnormalities to occur. So because they have a carcinogenic effect. There is one very famous study which has been done. I think it was in America, wherein or in London, I don't remember very well, wherein they have prescribed thalidomide to the pregnant women and all the abnormal children without limbs, they were born. Then they went back and found that all these women were prescribed thalidomide during pregnancy, early pregnancy, and that was the cause of birth of abnormal children. So they have stopped it. That is how the studies usually take place. There are 3 genes which are identified, which I already told you all. One is sex linked, the other is dominant and recessive, but both are autosomal. Autosomal, I told, how many chromosomes are there? There are 44. Please remember, 22 pairs. So, if there is skipped generation due to lack of penetration and unexpected pedigree patterns, it may result in diseases. So, one example which usually every physician speaks about is the G6 phosphate dehydrogenase. Next, what are the units of heredity? We inherit nearly 50,000 genes from mother and father each. And what do? Each gene will occupy a specific place in the nucleus, that is called specific locus. Locus means location. So, like for example, blood groups. The blood group, ABO blood group, that is chromosome 9. Y chromosome, testis. X chromosome, it is also related to hemophilia. I gave an example of sickle cell anemia. Another example is hemophilia. The X chromosome carries this gene in the females is the carrier of hemophilia and even color blindness, then muscular dystrophy. There are many diseases which have been identified by various scientists. So, chromosomal abnormalities. Chromosomal abnormalities can occur in number as well as in structure. Number, I already told you all. I gave you all the example of trisomies, Down syndrome, where the chromosome number is only 21. In Klinefelter syndrome, it is XXY. One is more. One X chromosome is more in number. Again, Turner syndrome. Turner syndrome, it is XXX. Again, one X is more. Like that, there are number of diseases which are linked with number of chromosomes. If the person has an exact number of chromosomes like 44 autosomes and 2 sex chromosomes, then they are normal. Otherwise, they are abnormal. So, the various diseases they have identified based on the number of chromosomes. Coming to structure as such, there are 7 things which can occur in the structure of a chromosome. One is non-disjunction. Disjunction has to take place when there is a division of chromosome. When it does not take place, then it results in abnormality. We'll see what are the diseases, how it takes place. Then the other one is translocation. Instead of, if X has to be on my left side and Y has to be on my right side, there is translocation, that the Y goes to my left side and the X comes to my right side. And because of the translocation, it results in an abnormality, and that is chromosomal abnormality. And what is deletion? Deletion is when you look at the structure of the chromatids, chromosome, what happens is a part of the chromosome, a bit of it, a part of it, it gets deleted during division. That deletion has a major role on abnormality, chromosomal abnormality, which results in abnormal child, birth of an abnormal child. And other thing is about duplication. When they are dividing, they have to divide exactly into 2 halves. But some of them, because of the various factors which I told you all, it becomes duplication, more number. When they are duplicated, again it is presented as a chromosomal abnormality. What is inversion? Inversion is they had to multiply in one order, but instead of that it gets inverse, and that will result in again chromosomal abnormality. Similar way, isochromosomes, similar chromosomes, they look similar, and then mosaicism. That we will see how what it is and how it is. Non-disjunction. What is non-disjunction? Look at this picture which I have posted. I have put in the slide. When you see at the normal and abnormal, both, non-disjunction meiosis. What is happening when you look at the first picture? It is exactly, it has become out of 4, 2, 2. Here there is nothing. It is empty. This form of division, no normal gametes here because of the division, that is called non-disjunction event. Then again the second event is also shown. It can occur in this way also, like 4 they have divided into 2 chromatids in each, and again only 2, but again here abnormality, here 1 1. So they are here it is 4 2 1 1. This is normal. Here it is 4 2 2, but 1 is empty. Then this is abnormal gametes. So here there are no normal gametes at all in the first picture. So these are called non-disjunction meiosis. What happens? I already told you all, in the nuclear division it usually occurs during gametogenesis. The examples are monosomy, trisomy. Trisomy is I told about Down's syndrome. Monosomy, there are some other diseases which you will come across in your pathology. Translocation, I was telling you all how they get located. Translocation, it will get transferred to the other abnormal place. For example, you see here, what is this? Before translocation, what happened? This is the chromosome. Forget about the name, number. Here, this 1, 2, 3, this part of the chromosome, when it has to go, it has to actually it should be again get exactly like this, it has to come out. But what happened after translocation? This part went here and the remaining part here went here. So it is nothing but it is getting translocated, locating somewhere else instead of in the right place. That is called translocation, which will result in abnormality, chromosomal abnormality. Deletion, you can see here, this is a normal thing which it has to exactly be like that when it is after the nuclear division. But what is happening? This part of the chromosome is breaking up. It breaks down and then it gets deleted. Once it gets deleted, it is becoming shorter when compared to the normal size. When it becomes short, it is not the normal chromosome after division. So there is a disease because of the shortening of the chromosome. This is called deletion, deleted genetic material. That deletion can occur because of various factors. Are you all with me? Yes, no? So whenever there is a deletion, there is severe incompatibility in the newborn. There is severe incompatibility. Why? Because it has become short. A part of the chromosome is missing. It has got deleted. Got it? Okay. Then comes your duplication. Look here how the duplication took place. this part of the chromosome, it has again become double. Got it? Here you can see orange and green, again orange and green as repeated. This part of the chromosome is duplicated. Once it is duplicated, what happened to the size? It has become long. It is long. I repeat. So again there is incompatibility in the newborn because of the duplication. In deletion it has become short. In duplication it has become long. Both have incompatibility in the live birth of the child. Inversion. What is inversion? Look at this picture. Here the chromosome has broken and then instead of orange and green it is getting inverted, and after inversion it is getting reinserted in the piece of the DNA. So the orange, instead of being above and green down, green went up and the orange went down. So what happens? The expression of the DNA or the gene is different from normal gene. So that will result in abnormal live birth, incompatible live birth. Then this is called paracentric inversion. Paracentric here. Okay. What is pericentric inversion? In pericentric inversion, again the chromosome breaks, and here at the center, what is center? I told, wherever it gets located in the center, it is called centrochromia. I told you all in my previous slide. After that it gets inverted, and then what happened? Again it gets inverted with the DNA with centromere. Centromere is at the center point it gets located. So this is the inversion can be at paracentric level, the inversion can be at pericentric level. What are isochromosomes? The isochromosomes, when you look here, the two pictures here, this is one and the other one. Let me not tell you all about P arm and Q arm because it is too much for you all as undergraduates. Let's think that they are the two chromosomes. And then what is happening? This is the centromere. And then here, both of them, they join here. They join here. And then what is happening? These two, they are getting adhered to each other, and the other two getting adhered to each other. Okay, and this has become very short, this has become very long. Both have the effect on the chromosomes, and it will result in incompatibility of the live birth, which the mother gives birth to the baby. So it is a special class, and it is structurally abnormal chromosomes. What are these? They are structurally abnormal. All these things, what all I spoke till now, they are all related to the structure. Are you all with me? Then comes our mosaicism. What is mosaicism? This is the normal cells wherein you will see 46 chromosomes, 44 autosomes and 2 sex chromosomes, and here you can see one cell missing a chromosome, that missing X chromosome. There is no X chromosome here, so it is only 45. So this is how chromosomal mosaicism looks. If it is normal, here the color, you can see the color, and they exactly are like this. But this one which is not having X chromosome, it will present in this way. This representation of the chromosomes on the body, that is the chromosomal mosaicism. What is Mendel's law? Can anyone tell me what Mendel's law is? What is the law? The Mendel's law tells that unit characters, they are on the basis of inheritance. How you inherit from your mother and father. That is the law of unit characters which you get from your parents as you inherit it, and it is based on two laws. One is law of dominance and the other is law of segregation. Dominance, I said, whoever dominates, like in the genes, their characters are inherited by the individual. And the segregation, how the genes get separated. Based on that, we get our characters. Okay. Then comes this is Mendel's law. So classification, based on the classification of the abnormalities of the embryo or the fetal wastage, they have found that they are more than 300, equal to or more than 300, and they are mainly based on Mendelian factors, which I told you all. There are two laws, one law of dominance and the other law of segregation, and it is mainly multifactorial diseases. What is the magnitude of the problem? The magnitude of the problem is the incidence. What is incidence? Do you all know what incidence means? Or you all taught epidemiology? Incidence is the new cases which occur. So according to that, it is 5.6 per every 1000 live births. The incidence is 5.6 of them are born like that. And how many of them have sex problems which are inherited from sex chromosomes? 2 per 1000. And then the autosomes, from the autosomes it is 1.7 per 1000. And translocations, the incidence is 1.9 per 1000. All these are related to the incidence of the abnormalities based on the genetic disorders. Abnormalities of sex chromosomes. What is Klinefelter syndrome? I told XXY. So one X is more, though the person looks like a male person, still because of the extra X chromosome, he is not a normal man. And what is the incidence? The incidence is 1 per 1000. And the other syndrome, it is XYY, wherein the Y chromosome is in addition to normal XY sex chromosomes. So this is an XYY syndrome. The incidence is again it is 1 per 1000 births. Then the Turner syndrome, which I told you all, it is X0. And then there is missing X chromosome. Instead of XX or XY, it is only X0, which you will come across, and it is, the incidence is very high. It is 1 in, incidence is low when compared to Klinefelter syndrome and XYY syndrome. It is 1 in 7500. And super females, it is XXX. And related to autosomes, which we usually come across, is our Down syndrome, that is also called Mongolism, and it is trisomy 21. And what is the incidence? It is 1 in every 900 births. Please remember that. And I don't know whether you will be seeing this case here or not, but in Nilofer Hospital we have seen a number of Down syndrome cases. Yeah, this is how the baby looks. The abnormalities, Mongolism, trisomy 21, which again I have put it so that you will remember that it is the defect in number of chromosomes, and the incidence is 1 in 900. It is a public health problem because no parents like to have an abnormal child. They want to have a live child and a healthy child. And then how does this Mongol look like? He or she is short stature and with small rounded head, the development of brain is it's abnormal because very small head, so the size of the brain is also very small. They have narrow tilted eye slits, very narrow, and then malformed ears, then short broad hands, lax limbs without tone, and then they have mental retardation. If you get a chance, you can just you'll be lucky to see. Otherwise, I think I do not know about the pediatric load here, how many come here. Okay, I will stop here. I will catch up you all in my next class. I'll start with autosomal dominant traits in my next class. Now the time is up, so wish you all a good day today. Started with my class. Thank you all very much. Have a good day. Bye.